Welcome to our YouTube channel. I'm teacher Mark from Can Study, and for this video, we're gonna cover the fraction divisions. Starting out with a simple concept. Over here, we have a calculation which is 2 over 5 times 5 over 2. Now, what will be the result? Very good. You must be giving me the 1. But why is it the 5? Denominator cancel with the numerator 5. 2 and 2 cancel out. Will be left will be just 1. Very good. But next one. How about 7 over 9 times 9 over 7? And the result also should be 1 because 9 and 9 cancel out, 7 and 7 cancel out. It's just 1. And next one, we have 1 over 5 times 5. What will be the result for this one? The 5 denominator cancel out with the whole number 5. So the result also equals to just 1. So from the above 3 examples, let's take a guess. We have 4 over 7 times which number to give us also product equals to 1? You must be smart enough to give me 7 over 4. So we can see the denominator of the first number actually became the numerator of the second number. And the numerator of the first number actually became the denominator of the second number. So it's actually the fraction we are using. It's actually flip it around. Flip it around. And then we are calling this kind of numbers as reciprocals. Reciprocals. Flip it around. We call this as reciprocals. But the definition of reciprocals actually means, you can see over here, every this kind of two numbers times together, we have the product of 1. We have the product of 1. So for every two numbers product equals to 1 is called reciprocals of each other. For example, 4 over 7 is the reciprocal of 7 over 4 because they have the product of 1. And 7 over 4 is also the reciprocal of 4 over 7. Is reciprocal of each other. And then from the previous example, 1 over 5 is the reciprocal of 5. And 5 is also the reciprocal of 1 over 5. That's how we said. Now, after that, let me show you some examples. A very simple calculation, we have 6 divided by 3 equals to 2. Very simple one. But if you're using a model to represent, over here we have a model to represent 6. But how to divide by 3? How to show divided by 3? Yes, very simple. We just need to cut it into 3 parts. And the 2 is just what we get, the one part of it. One part of it is 2. Now, that's for divided by 3, we get 2. But how about 6 times 1 over 3? And it also equals to 2. We need to show that. Still, we have a model, but how to show times 1/3? In this case, times 1/3 actually means we're dividing this into 3 parts. And we take how many parts? And we take 1 part. And the 1 part is just 2. Now, let's compare this to calculation. Over here, we have divided by 3, we cut into 3. And times 1/3, we also need to cut into 3. So actually from the meaning, the divided by 3 is actually equivalent to times 1 over 3. Now, what is the relation between 3 and 1/3? We can see the 3 and 1/3 is actually called reciprocals. They're reciprocals. So from these examples, we can know a whole number divided by a whole number is actually equivalent to a whole number times its reciprocal. A whole number divided by a whole number is equivalent to whole number times reciprocal. After that, I have a question. Does it only refers to whole numbers? Let's show you some more examples. For example, over here we have a fraction divided by a whole number. Isn't it still the same? Now, for example, over here, let's show it by using a model. The 3 over 4, we can use a pizza to represent. But it's not a whole pizza. It's not a whole pizza. 3 over 4, we need to cut into 4, and we take only 3 of it. That is 3 over 4. And for this existing pizzas, I need to distribute to 3 students. And that's the meaning of divided by 3. From there, we can see every student will get one fraction of a pizza. In this case, every student will only get 1/4 of a pizza. So the answer is just 1/4. But after that, let me show you another example. 3 over 4 times 1/3. We know how to use fraction multiplication. So the answer is just 1 over 4. The 3 and 3 cancel out. But also from the meaning, the 3 over 4 pi, cut into 3, take 3 parts, and times 1/3. Also serve as this existing parts. We need to separate into 3 parts, and we take 1 part. So still the same. Each part is actually 1 over 4 of a fraction of the whole pizza. So the answer is 1 over 4. So from here, we can know the divided by 3 is actually equivalent to times 1 over 3. But the length number, does it matter? Does it change? It doesn't change. And it doesn't matter whether it's whole number or fractions. So let's change the whole number of the left side to any number over here. So any number divided by whole number is actually equivalent to time its reciprocal. But then, how about right side? This right side only refers to whole numbers. Let's move on. Give us some more examples. Over here we have 3 divided by 1 over 6. The 3, we can think of it as 3 pizza. How about the 1 over 6? We can also use a pizza to represent. This pizza A is durian pizza. But I don't like durian, but to show 1 over 6, I need to cut into 6 parts. And I only need 1 of it. And that's 1 piece. So the meaning of 3 divided by 1 over 6 is actually meaning inside the 3 whole pizzas, we have how many 1/6 pieces? We have how many pieces? And we need to divide each by 6. And we have a total of 18 pieces. That's what we can get from the models. But after that, we have another calculation, which is 3 times 6. What do we get? It's nothing but 18. Now, we have the same result. And actually, the meaning is still the same. Divided by 1 over 6 is actually equivalent to times 6. And the 1 over 6 and 6, the relationship is reciprocals. They are called reciprocals. So now, at this moment, the right side is not only refers to the whole numbers anymore. It actually refers to the fractions also. It actually refers to any number. So for any number divided by any number, it's actually equivalent to times its reciprocal. Now, let's move further. Previous examples, we only have 1 over something, 1 over something. What happens if we have 3 divided by 5 over 3? Is it still the same? Actually, by guessing, it should be 3 times. I flip it around, 3 over 5. But the problem is how we can prove that. Able to prove that, let's do a revision. Let's do a simple revision. Over here, 3 over 5 times 5 over 3 equals to how much? Just equals to 1. Very good. But then, if we use the product 1 divided by 1 over the term, which is 5 over 3, what will we get? You must be smart enough to give me the 3 over 5. But let me show you some examples to prove that. So over here, we have 2 times 3 equals to 6. So 2 numbers times together, we have a product. So the product 6 divided by any of the terms we'll get is another term. For example, 6 divided by 3, we'll get another number, which is 2. 6 divided by 2, we get another number, which is 3. So same thing for this fraction division. So 1 divided by 5 over 3, what we'll get will be another number. So which is 3 over 5. So from there, let me test you a little bit. So 1 divided by 3 over 5, the first number, what do we get as a result? What we get will be another number, which is 5 over 3. So from this example, we can know 1 divided by any number, what we'll get will be its reciprocal. What we'll get will be its reciprocal. And the 3, the previous one, the first example, we have 3 divided by 5 over 3. The only difference is we're not having 1 but 3. So let's change it a bit. How about let's change it to 3 number of 1. So we actually times it to 1. So over here, we have 3 times 1 divided by 5 over 3. And by times 1, it doesn't change the result. It doesn't change the result. But over here, we can calculate the right side first, which is 1 divided by 5 over 3. And what will be the result? It just 3 over 5. It's reciprocal. Now, we're transferring 3 divided by 5 over 3 to 3 times its reciprocal. And the final result will be 9 over 5. But actually, when doing the calculation, we can just skip the 2 steps. The first 2 steps is just how you prove that. And move up. So divided by a fraction is actually equivalent to time its reciprocal. Flip it. Time is reciprocal. And then, let's move to the next step. How about fraction divided by fraction? So we have 3 over 4 divided by 3 over 8. And from the meaning, we can also still use pizza to represent. 3 over 4 is just cut into 4, take 3, and that's 3 over 4. Another number, 3 over 8. We cut into 8 pieces, not just 4 pieces, we cut into 8 pieces. But to maintain the same pieces, the left side, we also need to cut into more. And then, moreover, we have 3 over 8. That means we only left 3 pieces for the right side. And from the meaning, the left side is including how many right side? And the answer is just simply 2. 2 times. The left side is actually 2 times of the right side, so the result will be just 2. Now, we can do this calculation in another way. For example, over here, we bring a 1 inside. We times 1. So the whole calculation actually changed to 3 over 4 times 1 and divided by 3 over 8. And then we calculate the right side, which is 1 divided by 3 over 8. What we get? What do we get for this one? What we get will be its reciprocal, which is a over 3. Flip it. So it became 3 over 4 times a over 3. And then we simplify and finally get 2. Now, that's how we do the fraction calculations. So let's do a summary for this one. For the number in the left side, do we change or not? We do not change it. But the division sign, we change to multiplication sign. And the number in the right side, we're changed to its reciprocal. And how to change it to reciprocal is we're actually flipping around. Flip around. Now, moving on to some practices. So for the first one, we have 8 over 9 divided by 4. So to do this calculation, first, the left side, do we change or not? We do not change, so keep it. And the division change into multiplication, and the 4 need to change into its reciprocal, which is 1 over 4. And then we do simplification, which is 8 cancel with 4, and what will be left will be just 2 over 9. Now, let's move on to next step. Over here we have 11 over 12 divided by 5 over 4. So still the same thing. The left side, should we change or not? Not change. And the division should change to what? Division should change to multiplication. And how about the 5 over 4? How do you change 5 over 4? Yes, we flip it. We flip it to become 4 over 5. So let's copy it out. So on change, left side times 4 over 5. And then what should be the next step? Very good. Not multiplication, but instead we should do simplification first. So 12 and 4 can be simplified with 1 and 3. So in this case, we have 11 times 1 and 3 times 5, 11 over 15. That's how we solve the problem. So for fraction divisions, we have also certain steps. For every fraction divisions, the first step will be change it to multiplication first. And then we became the question that we know, and then continue on for fraction multiplications. First is still division, simplification, and then is multiply. So for 3 steps, change into multiplication, simplification, and multiply. So 3 steps. And by knowing how to do the fraction divisions is not enough. To master it, we must do enough practices. So over here, I prepared 5 practices for you to practice on. So you can pause here and try those questions yourself. You can also write down the answer in the comment section below. And then, if you want to know more about PSLE, you can try to contact me by scanning this QR code. Either join our study group or contact me directly. And that's basically all for this video, and see you next time.